Hi, and welcome to Software Unchained's Clueless project. First, we're going to introduce the team here. We have Gerald Vincent, Keith Chasen, Rebecca Friedman, and Greg Hilston. Gerald has his business economics degree from the University of California, currently working as a systems analyst at Palo Verde Nuclear Generating Station, and he enjoys mountain biking, snowboarding, and playing guitar. Keith has his computer science degree from Binghamton. He currently works at the local hospital focusing on data, dashboarding, and reporting, and he also works part-time as a critical care technician and EMS dispatcher. Rebecca has her computer science degree from George Washington University. She's currently employed in the DC area with a focus on Java, JavaScript, and Python. She enjoys punching things in martial arts, kayaking, and practicing guitar. Greg received his computer science degree from the University of New Hampshire. He currently works at a small marketing and design company developing mobile applications. He enjoys hiking, video games, and playing pool. For the project overview, we were asked to write a simplified version of the popular board game Clue. For those of you who don't know, Clue is a murder mystery where the players are spending their turns moving from room to room and making suggestions on who the murderer is, involving the room, the person, and the weapon. For our particular application, it's an online multiplayer game. The simplifications that we were asked to include are involved with the size of the board game and how movements are handled. And with that out of the way, let's move to the technologies used section. Before we actually started writing any code, we as a team came together and decided what technology we wanted to use to make our lives easier and also to explore new opportunities that we might use in future projects and even work. So we went with Django. We have the Django templating language, which is really cool. It allows us to basically bring Python code into the HTML. We went with the RESTful API. We have a Postgres database. Obviously HTML and JavaScript for our web app, Docker, which we'll get into, GitHub, and Slack/Google Hangouts. A RESTful API is a specific kind of API that uses HTTP commands like post and get to interact with the backend. What's great about this is we had extendability in mind where we could create one API and have our web app have the front end, but we could also have the front end for like an iPhone app, an Android app, or any other desktop application and still use the same API, so a common interaction endpoint. API unit testing is really easy with Postman. You can create suites of tests and run through them automatically. We didn't do this, but we discussed it and thought it'd be a great way to continue this project if we ever wanted to. And like we said, HTTP commands like post and get, it synergizes really well with web frameworks like Django. Docker is an awesome way to create VMs, which they call containers. We followed the theme where each container does one job but does it well. So we have 3 separate containers as you can see at the bottom. One for Django, one for Postgres itself, and then its data. And they all interact with each other separately. This protects us against environmental differences. For example, across our 4-man team, we used Mac, Windows, and Linux. And we saved ourselves all the headaches of having to deal with the 3 different environments by using these containers on each system. And with the small time investment of learning how to set this up, it's going to pay off throughout the entire project, where we might have specific commands we'd have to run in Windows or Mac. When we use Docker, we don't have to deal with that because it's all Docker VMs under the hood. So now we're going to move into GitHub and how we used it. So GitHub is a website wrapper for the popular version control program Git. We used it to help alleviate the remote teammate aspect of this project, where none of us even live in like the same state. So branches allowed us to work on features and bugs independently from each other and handle merging back into the master when we were ready to go. And by merging, we used pull requests, allowing us to do mini code reviews. So we got to eliminate bugs early on and save time throughout the entire project. And the final thing I want to talk about is Slack and Google Hangouts. Slack is a popular chat much like IRC, and Hangouts also has a chat feature, but also a webcam and microphone aspect of it. We used it to have instant team-wide communication, and it also made our weekly Scrum meetings very easy because we could see each other and all talk in an open forum discussion. So with our technology stack discussed, we're going to move into the project management aspect. So now for the project management tools. Like we previously discussed in the technologies used section, we had GitHub, Slack, and Google Hangouts to help the team, so I'll make the next slide on those 3 topics a little short. We'll then talk about Trello, the weekly Scrum meeting, and the team documents. So GitHub, Slack, and Google Hangouts. What was nice about it is the entire team was completely remote, so we could use the GitHub branches and pull requests, the Slack chat room notifications, and Google Hangouts video and audio chats to make meetings online very easy. We were able to have some discussions in real time over voice, which was very helpful. And also pair programming was pretty sweet. When two individuals would have a similar problem, they could work together in a voice chat or their own channel on Slack and work through the problem instead of doing it on their own and emailing back and forth like you might have done without these tools. So Trello's an online tool that allows groups to organize their work. As you can see here, we have a bunch of different sections. I want to primarily look at the to-do section. So here we would make all our tasks that needed to be done. We could assign them to specific people, as you can see with our initials and pictures. We could also put down due dates, and other members of the team could comment on those tasks. The next thing was the in progress. So when someone started working on a task, they would just move it from the to-do column to the in progress. Again, they could further document how far along they are, or if anything is blocking them. And the final column we have here is the done column, which is where all the tasks would move when they're done. This was a snapshot from a while ago, but as you can see, tasks would be created to do and flow through in progress and done. And now we can talk about how our team used Scrum. So Scrum is a technique and basically a weekly meeting that a lot of projects and companies use. Essentially, the three questions that we were asking in every Scrum was, what have you done since our last meeting? What do you plan to do before the next meeting? And is there anything blocking you? So with each individual person answering these three questions, it really summarizes the week of work and the planned next week of work for the entire team, making an online project a lot easier to manage. And the last thing we have to talk about is the project documents. So the class asked us to create these 5 documents. I can talk about what they kind of did for us. So the team charter was the first one, where we kind of wrote a small bio, getting to learn each team member. We also defined the rules of behavior and discussion conflict resolution, which we didn't actually have to use. We generally were all on the same page and kind of could be convinced of the correct way to do things. The next document was the project plan. We defined our own internal milestones and also the defined milestones by the class, and the activity list / Gantt chart, which allowed us to schedule and kind of figure out if we were on track or not on track with how the project was going throughout the semester. The third document was the vision document, where we defined the stakeholders, user goals, and needs. This was helpful to keep reminding us of who the actual users were for this program. There were the developers, us, the professors and TAs that graded us, and then other classmates who might be looking at our code or project. The fourth document was the requirements document, where we just defined our functional, non-functional requirements and also use cases. So again, when we're working on a bug or a feature, we could always tie that back to one of the actual functional requirements or use cases. And the last document was the design document, where we defined the class diagram and system operations. This was the one that was most helpful with writing the code. We were able to just look back at the class diagram and the system operations and just tie it all back together with our initial design and refactor if needed. And with that, we're going to move on to our demo. So here we have 2 instances of our website. The one on the left I'm going to refer to as player 1, and the one on the right I'm going to refer to as player 2. So let's quickly create an account for both our players. And if we've done this correctly, we'll be greeted with the login screen for both our players. So I can log us in now. And now we're successfully logged in. Some places of improvement we could make if we had more time or wanted to extend this project is we could do some email verification. Also, common passwords we could disable. Django provides us some of that, but we could actually extend a lot of that and just make sure that the passwords can't be too unsecure. So now that we've demonstrated creating an account and logging in, I'd like to demonstrate how easy it is to create a game. So player 1 is going to be our host. So we'll go on the left side of the screen, we'll start a game, we're going to name this Demo, and of course I'm going to play Colonel Mustard. So start the game here. Notice how we can't begin the game because only one player is in here. This is a requirement that we imposed upon ourselves just to make sure that there isn't an instance where a single player is trying to play a game, because it'd be the only one playing and it just becomes a little weird. So on Player 2's screen, we can navigate to the lobby. We can see other games that we've made during testing, but here's the one that we have with our demo Player 1 account. It hasn't been started. You can see some more information like the date and the time. So I can simply join the game and we'll play as Miss Scarlet. So now we load it in on the right. Player 2's game is up to date. On the left, Player 1's requires a simple refresh to see that all the players are in the lobby ready to start the game. So that is how you create a game and join a game. Okay, so now I want to show how simple it is to start the game. Once the minimum number of 2 players are in the lobby, the game can be started by the host. Right here the message is told to all the players the game will begin when the host starts. So as the host, as Demo Player 1, we can begin the game. So on the host side, the game has begun. We can see all the suspects, the rooms, and the weapons, just like the sheets you would get in the actual box. The map here is our 3x3 grid, and your moves, informing us it is our turn. With Player 2, a simple refresh brings up the game, informs us that it is not our turn, but we also have the wealth of information that Player 1 has as well, the map and its own detective sheet, and any extra notes they'd like to take. So now the game is started, and it's Player 1's turn. You can see that again in the game actions here. Before we actually make our move and do our turn, I'd just like to show you that the detective sheet is also notifying us of what cards are in our hand. So with our Player 1, they have Colonel Mustard, Miss Scarlet, Mrs. Peacock, and Mrs. White in their hand, whereas Player 2 only has Professor Plum. Same thing for rooms and weapons. We can just see from the little book here what cards are in each hand. So now if we're taking the turn. So Player 1, Colonel Mustard, he's out here in the hallway. His action is going to be to move himself. And if we take a look at the rooms he has again, he does not have the lounge, so that makes sense for him to want to move there. He moves himself to the lounge, as you can see updated on both player screens automatically. He's able to make a suggestion. Let's go ahead and say that. Great. So if you remember the rules from Clue, the room that we're suggesting is the room that we're in. So in this case it's the lounge. But we do get to pick the suspect and the weapon. So the suspect makes sense to do Mr. Green or Professor Plum. And instead of scrolling down here every time, we also have a handy little notification in here. So we'll pick Mr. Green, and we'll look at the weapons, and we'll just pick the wrench. Click Submit. So now Player 1's suggestion has been made. Player 2 will be notified of our suggestion, and then allowed to show a card. Player 2 only has one card, the lounge, which they can submit and send back to Player 1. So now Player 1 has finished their suggestion. They are notified that Player 2 had the lounge card revealed here. And now we have the option to make an accusation or end our turn, which we will do. When we end our turn, the server will notify it's not our turn on Player 1, and Player 2 will now be notified it's their turn, starting the same cycle we just showed. Player 2, playing Miss Scarlet, is in the hall right up here. In the hallway, excuse me, can make a move, make a suggestion, and follow it up with an accusation if they choose. So now I'd like to demonstrate making an accusation. It is Player's 2's turn on the right, and we're going to make an accusation that's going to win us the game. If we were to take a look at the cards that Player 1 has, and the cards that Player 2 has, we can find out that the actual solution to this game is Mr. Green in the library with the wrench. So just knowing that, we're going to move Miss Scarlet from this area in the hallway to the library itself. That should update on both screens. And we'll make our accusation. Again, it's Mr. Green in the library with the wrench. Notice how we have a drop down now for which room? This is because we're making an accusation. So an accusation, you can pick any room, or a suggestion, you have to be in that current room. These are just the rules of the game clue. So we'll submit. And we get our message that we have won. And player 1 gets the message that they have lost. So that is how the game would be played. And that's a demonstration of an accusation. So another thing we wanted to demonstrate was the UI on a full screen. Previously, most of the demonstrations have been done with 2 windows, one on the left, one on the right, both taking up half the screen. But as you can see here, when the game is given the full screen, the map snaps up, taking advantage of all the real estate it has. I'm also going to demonstrate what it looks like on a mobile device, which is the demo player 8 in this game here. So here we have the mobile UI on an Android device. You can see that we have the menu on the top right with the hamburger icon. We also have the title Clueless in the top left. The map and our detective sheets are all here, like expected. So the game is fully playable from a desktop, laptop, tablet, or phone device. So here we have a game with the maximum number of players, 6 players total. As you can see here at the top, I have a separate tab for each player, and the UI is updating for each of those players. So the first thing I wanted to demonstrate with this game is that you can tell it's already been started. So if we were to take a 7th player, all the way down here, who would look at the game lobby and see that our demo for 6 players is already started, they do not have the ability to join the game. So we have that restriction in place. Second thing I'd like to demonstrate with this game is that it's Colonel Mustard's turn, and he's able to move to the conservatory using the secret passage that connects them. I'm going to fast forward a few turns to show that we have movement restrictions for 1 player in the hallway. So now I have the same game up, fast forward a few turns to Professor Plum's turn, who's in the library. If Professor Plum wanted to move, we can look at the valid move options and see that moving to the conservatory hallway is not allowable. And that's because Mrs. Peacock is already there. This is important because the rules state that only 1 player can be in the hallways at any given time. So again, we have restrictions on the server side to ensure that the players are following the rules. So I loaded up a new game. I just wanted to show you guys that we have a lot of restrictions in play to stop players from cheating. So currently it's player 1's turn. So they can do all the actions we stepped through previously. Moving, making an accusation or suggestion when they're in a room. But as you noticed, player 2 doesn't have any ability to make these actions. So that's stopping them from taking turns out of order, making sure that the game state is valid the whole time. Another thing that's interesting here is that player 1's position is between the lounge and the dining room. And if we ask to move, we only can move to the lounge and the dining room. So the moves all have to be valid moves. This includes the secret passageways and all of that. So the restrictions that we put in play on the server side ensure that nobody can be making moves out of turn or illegally making suggestions or accusations. Essentially, it stops people from cheating and making sure that our game state is always valid. So with that, we've walked through all the features of Software Unchained's Clueless project. We met every feature that was asked of us, and believe that stepping out of our boundaries to make a web application was a great learning experience and will help us in our professional and educational career. Thank you.